Hello and welcome everyone. In the session 1, we discussed about basics of Python, the installation and execution of our first program. Also, we discussed about the formation of a program, the basic elements of Python language. In this session, we are going to discuss about variables, expressions, statements, probably conditions, one-way decision, how is the decision making done in Python, and so on. So let's get started. Let's see what constants are. Constants are fixed values such as numbers, letters, and strings. Why they are called constants? Because their value does not change. Numeric constants, like the numbers, as you can see over here, you have this number 1, 2, 3. You're trying to print it and you get the output 1, 2, 3. String constants use single quotes, double quotes, and even triple quotes. Alright, so how do we represent strings in Python? Is using one of these, that is either single quotes, double quotes, or triple quotes. An example of string literal or a string constant is this: hello world, which is inside the single quotes and is printed out. Alright, what are variables? Variable, as the name says, their value can change. So it is what? It is a named place in the memory where programmer can store data and later retrieve the data using the variable name. So name of the variable is the key to accessing the value stored in the variable memory. So programmers get to choose the names of the variable. We'll see how and what are the rules the programmer should keep in mind while defining variables. There are certain rules. We will discuss about that. And you can change the contents of a variable in a later statement. That is, we'll see how this is done. So as you can see here, x is a variable. In fact, the name of the variable is x, which is holding the value 12.2 is the value, or you can call this as a constant. It is not a mandatory requirement that the value has to be constant. It can be assigning one variable to another variable. We shall discuss about that. And welcome Yan Wang. So probably I will unmute you for this session so that you can ask questions over video if you have any. Can you hear me?
Yes, I can.
Thank you. So I have unmuted you. All right.
Okay.
Okay, so if you have any questions, you can ask me over audio itself.
Okay, got it. Thank you.
Yep. So we'll carry on.
Mm.
All right. So as we were discussing about variables, or we will do one thing, that if you have a question, you can just raise a question on the questions window, and then I shall unmute you. Is that all right? All right.
All right.
All right. Thank you.
Mm.
So we were discussing about variables, and as we saw, the name suggests. So variable is a named place. You give a variable a name, and it holds a memory where programmer can store the value or the data, and at later point of time we can access the data through this variable. So as you can see, we assign the value 12.2 to the variable x, and we had this 12.2 in the memory. The box represents the memory. All right, and this memory region has the value 12.2 right now, and this memory has the value 14, which y is representing. Now in the next slide we tried changing. There is a bit of overlap. I think you will have to focus more. So x is equals to 100. I will rewrite it over here. X is equals to 100. So we tried changing the value which was represented by x, and see now the value is not 12.2, it is now 100. All right. Okay. And as we were discussing that there are certain rules that needs to be followed while giving your variables a name. We saw that we gave our variable a name x. X is equals to 100. All right. Now, giving your variable a name has certain rules. And what are the rules? The rules are the variable name must start with a letter or an underscore. This is the first rule. Second, must consist of letters and numbers and underscores. Special characters, so that means that it has to be only one out of these. Letters and numbers, so we can call this as alphanumeric, that is alphabets and numbers, and underscore. No special characters allowed. And it is case sensitive. This is the third rule. So let's see what are the examples we can do, what are good and what are bad. Bad in the sense they are not allowed. Spam is a valid variable name because yes, it has all the alphabets, and we know that. So the first rule applies, the variable name starting with alphabet. So this holds good, and must consist of letters and numbers and underscores. So rest of the things are also satisfying this condition, that is they are one of these. So in this case they are all alphabets. So in this case also x is also alphabets. This one starting with alphabet, true, and yes, it has numbers but not in the starting point, and since rest can be numbers is also valid. This particular variable name, Now this variable name is starting with underscore, which is also a valid. Let's see some bad variable names which should not be followed. This particular variable name, it starts with number and it is not valid. This particular variable name hash sign starts with special character and again this is not valid. The third one is also not valid because it has a dot character in it. Alright. Now what we meant by case sensitive is small letter spam and capital spam are both different. So these both, or in fact all these three are different because of case sensitiveness. I hope we now know how do we give our variables a name, a valid name. In the last session we discussed about reserved words and let's just recap what are the reserved words. Reserved words are words which are reserved for use by Python. So it should not be used by the programmer to define either variable names or function names and so on. Alright. This is the similar example we saw in the last session also, that the words form sentences. And these are the three different forms of sentences we saw in the last session. Assignment, assignment with expression, and the print statement. Alright. Now let's see what do we do in an assignment statement. So in an assignment statement, we have the operator, which is the assignment operator. This is the assignment operator. And now the right hand side of the assignment operator can be just a value, can be a variable, or can be another expression. Expression which evaluates, so expression which evaluates to a value or a variable. Alright, now let's have a look at this, what it evaluates to. So we are trying to evaluate this expression. This expression says 3.9 multiplied by x multiplied by 1 minus x. X might be holding an initial value before this assignment. Let's say x has the value 1. Or let's not take, so this becomes 0 in that case. Let's just proceed with 1. So in that case 1 minus 1 is going to be 0. This evaluates to 0. X is 1. This is 3.9 and 3.9 multiplied by 1 multiplied by 0. This particular expression evaluates to 0, which is then assigned to x. So this is how you can form an assignment statement. So to the right hand side of your assignment statement can be a value, can be a variable, can be another expression which evaluates to a value or a variable. Alright. Now let's proceed with a little more detail. Let's see, this is what we discussed in the last one. So x here has been given a value of 0.6, which is again 1 minus 0.6 is 0.4, and x is 0.6. So 0.6 into 3.9 into 0.4 is 0.93, which will be then assigned to x. Now what happens in the memory is x was holding 0.6. Now after this particular assignment, x will be holding not 0.6, it will be holding 0.93. All right. Okay. All right. This is what we saw. Correct? This is what we saw just now. Now let's see few of the operators used in numerical calculation, that is the mathematical operators. All right. So plus represents addition, minus represents subtraction. This star asterisk represents multiplication, represents division, the forward slash, double star represents the power, and this percentage represents the remainder. All right. Now let's see an example which goes through all of these operators. All right. Now we have xx as the variable, and this variable holds the value of 2 right now. Now what is happening in another statement is this is again another assignment with expression. All right, this is assignment with expression, and the expression is x plus 2. All right, so what happens is x already has the value of 2, so it is replaced by 2 here, added to 2, assigned back to xx. Now when we try to print xx, we get the value 4, which is the updated one. All right, this is the similar case with multiplication. Multiplication, what happens is these two numeric values are multiplied and stored in yy. Division, now what happens in division is yy is 5280. 5280 divided by 1000 is 5. Why it is 5? Because the remainder, since both are integer, 5280 is integer, 1000 is integer, so the remainder, that is say 5.280, should be the output. The decimal value is truncated. This value is truncated. It has been removed, and the output we get is the integer output. Since both the operands, now yy and 1000 becomes the operands. Both the operands are integers, and hence the output also turns out to be integer. All right. Now let's go to this example. In this example, we have 23 assigned to the variable jj. Now jj is divided. It is another division. What is this division? This is the remainder. This gives you the remainder after the division. So jj is 23. As you can see over here, 23 divided by 5 gives you 4, and the remainder is 3. All right, now what you get as an output of this operation is the remainder, as we discussed. All right, so you get the output as remainder. All right, let's see the last one, which is here as 4 double star 3. 4 double star is what? Double star is power. All right, the power gives you the raised to the power, which we know in mathematical is 4 raised to the power 3 is what? 4 into 4 into 4, which gives you 64, isn't it? All right. Now let's see another important aspect, and which is order of evaluation. How an expression is evaluated. We have a typical mathematical expression over here. All right. Now let's try to evaluate this particular expression. Now, in order to evaluate an expression, Python should know that which one should be evaluated first, because we have addition, we have multiplication, we have power, we have division, subtraction, all of them together. All right. Now, which one should be evaluated? Which one should be given preference? That is called operator precedence. All right. Which operator takes precedence over the others? Let's see. So these are the operator precedence rules which will be taken care when evaluating an expression. So which is given highest precedence? The parentheses are given highest precedence. Next comes power, next multiplication, addition, and what you see over here is the associativity. How are they evaluated? So they are evaluated left to right. All right, we'll see how it is. The thing to keep in mind is this, that parentheses are always respected. All right. Now let's see. Here is the pictorial representation of how the evaluation happens. This is what our expression is, and let's see how it gets evaluated. Now we know we need to remember this picture in mind when we are evaluating an expression. Now this says parentheses. Here we have parentheses. So 4 minus 1 is 3. This is evaluated first. Now next will be what? Power. Where is power? Oh, we have power here. So power is here. The 2 to the power 3 is 2 into 2 into 2, which is 8. We got 8, and our expression has come down to this particular expression, sub-expression. All right. Now, what comes next? Next is multiplication, or you can say multiplication and division. Multiplication and yes, exactly right. So it is division. So multiplication and division are equal in the priority of evaluation, but since our evaluation happens left to right, so in this case we have division and we have multiplication both, but since the evaluation happens left to right, the division takes place first, and 8 divided by 4 is 2. All right. Now and finally our expression is this. Now what happens? Addition and multiplication. Who will be given priority? The multiplication. And 5 into 2 is 10, and at the end addition, which is 11. So I hope this explains how the evaluation of an expression takes place, and at the end we get the value reassigned to the variable. All right. Any questions so far? Okay, we shall proceed further, and if any questions, we shall take that at the end of the session. Okay, what should we keep in mind? Though we have discussed the precedence rules, but there are few things which we should keep in mind while writing the expressions. Okay, first thing is we should remember the rules top to bottom. That is the top priority, number 1, and so on. All right, and the order of evaluation, that is left to right. Also, we should take care of, so what if we put a parenthesis over here? So parentheses, as we said, are always respected. So try to use parentheses wherever possible. This eliminates the errors. This eliminates errors. Why eliminates the errors? Because the developer doesn't need to take care of the evaluation because of the associativity. So he does not have to take care of either this will happen first or this will happen first. If he puts parentheses, he knows that parentheses are always respected and they will be evaluated at the first place. So try to use parentheses wherever possible. Try to keep expressions also simple enough. Don't try to complicate it. Try to write simpler expressions wherever possible. Also, try to break long expressions into shorter ones to make the evaluation more clearer. Okay, and this is what a partial of this thing we discussed, that we tried to divide an integer with another integer and the decimal value was truncated, isn't it? This part was truncated and we got the value as an integer value, which is not the correct value, in fact, but is sometimes needed, right? So this is what we discussed, that integer division truncates, all right? Floating point division produces floating point numbers, and here is the example. Integer division by integer division, since there is no remainder, it is the exact output as expected. Now let's see here, 9 divided by 2 is not exactly 4, it is 4 and the decimal values. Alright, but what happens is the decimal value is truncated and the integer value is the output. Alright, but at times we would need 4, at times we would need the exact value. And so we need to take care where we need integer value, where we need the exact value. If we need exact value, we need to take care of it by using floating point numbers. Floating point numbers, not integer numbers, like here. So this particular example gives the value as the floating point. Since there is no remainder over here, so it is 0. In this case, if this was applied using integers, the output is 0, whereas if you use floating point, that is the decimal numbers, the output is the exact output as expected. Alright, now what if we try to mix integer and floating? If we try to mix integer and floating, so the result is floating because the integer is converted to a floating point before the operation. Alright, what happens in this is one is integer, another one is float. The result will be float. Alright, I hope this is clear. So when you try to mix integer and floating, the result would be floating because integer would be promoted. This is also called promoting. So int is promoted to float. Alright. Now what does type exactly mean? We say that we have integer type, we have float type, we have string type. What exactly is the type? Type is nothing but the type of the data which we are dealing with, and hereby we are telling that what is the, let's say an example, x is equals to 2. We are saying that what is the data type which x is holding, what is the value of the what is the type of the data which x is holding. We're saying that this particular holds a number. All right, that we mean by the type. Now Python knows the difference between integer, number and a string. Since we said in the last session that it is a dynamically typed language. Dynamically typed. Since we said dynamically typed because Python knows what is the type of the data at runtime. So when you make an assignment like x is equals to 2, Python knows that we are assigning a number and hence the type would be a number. Alright. Okay, and it in fact also knows that when you are doing plus, that is addition we just saw as a numerical operator, and when we do plus on numbers, it knows that it is an addition operation. Alright, but when we do plus on strings, these are strings, when we do plus, this is called concatenation. Alright, now let's see, why does the type matters? Now let's see directly by the example. What we are trying to do in this case is we have two strings, string 1, string 2. We're trying to add them. Add in the sense just now we saw. What is this add? Is concatenating. The addition of strings is called concatenating the strings, and when we try to concatenate strings is in fact valid, and we get the result as the concatenated string, which is hello there. Alright, now in this particular line, in this particular statement, we see that we're trying to concatenate. Now since this is a string, this is a number, Python would treat it as a concatenation. Alright, and it will throw an error that cannot concatenate str and int objects. Alright, so we should not concatenate a string with a number. Let's see what is the type of the data which EE variable holds. So type function gives you the type of the data, and the type function works as you need to give type, and in brackets you need to give the data for which you want to test the type. And this particular type gives me str. It tells that str is the type of str, in the sense string is the type of the data you're looking for. Hello again is again a string, and the type of hello will give us str. Type of 1 gives you an int because it tells 1 is an integer. Fair enough. Alright. Now let's see, we just discussed about the overall perspective. That is, we just saw that we treat these guys as numbers, but in turn these numbers are also categorized. We'll see how. So we have xx is equals to 1, and when we try to get the type of xx, we get integer. Since 1 is an integer, though it is a number, but the subcategory is integer. Alright, we have another variable which holds the value 98.6 temp. When we try to get the value of temp, that is the type of the temp, we get float. So float is another type of number. and float represents the decimal values also. 1 is again integer. 1.0 is a float. Alright. Type conversion. This is an important function which will be used to convert the type of the data. Let's say I have a number 99 which I want to divide by 100, but then I want that my division should be exact. That is, it should give me the decimal values also. We try to convert this particular integer value 99 to a float using the function float. This float function is a type conversion function. This converts an integer to a float. So let's see, I is 42. We see the type of I. Since it is an integer, we get the type of the I as integer. Now we try to convert I, which was an integer now, and it is converted to float using the type conversion function called float, and f is the variable holding the new one. Now we try to see the type of f and we get float. This is one of the conversion functions. We can do the opposite of it using the int int function. All right, int function does the opposite. It will take the float and convert it to integer. All right, now let's see string conversion. We can also use another conversion function, which is, till now we saw int and we saw float. The third conversion function we are discussing about is str. All right, what str does, let's have a look at it. So str converts an integer or a float to a string. As well, variable here has the value 1, 2, 3, but since it is in quotes, remember, whatever we have inside single quotes or double quotes or triple quotes has to be considered as strings. And as well, type of as well hence is a string. We try to do the concatenation, which again fails, as we discussed that concatenation is not valid for different sort of objects. It works only for strings and strings. It cannot work for string and integer or integer and integer. All right. So now what we are trying to do is converting this as well, which is a string which holds the string 1, 2, 3. So now we are trying to convert this string 1, 2, 3 to an integer, which is ival. Now see, it is successfully converted and we can see the type of ival as integer. All right. And when we try to do an operation of addition, it works. ival holds the value 123, but not string 123. Rather, now it is the number 123, and we try to add 1 to it, which is 124, which is the output. All right. The last one is important. We have a string NSV, which is hello Bob. Now we're trying to use a conversion function int over NSV, and see, we got an error, invalid literal for int. So since this string does not contain numbers, and hence we get the error. This is an important aspect. You would be using these conversion functions very frequently for your day-to-day project purposes. All right. Okay. Now let's see how can we take input from the user. What is the way to take input from the user? So user probably would be giving input from the standard input, that is from the keyboard, and let's see how can we do that. The raw input is the function to do that, right? So raw input takes a string as an input, but remember this string is not processed. Okay, this is just for displaying to the user a help or an example string what he needs to enter. So let's see what we are trying to do here is we have the function raw input. It takes the string who are you as an input. Now this is a help string which will be displayed to the user, telling that what is the input, what is the type of the input the user is looking at. And user is asking who are you, is asking us the name, and what it returns is this. The raw input function returns a string. So whatever the user has, in the yellow part you can see this is the input from user, Chuck, right? So this Chuck will go as a string. So this NAM, probably it is a misspelled one, so it is NAME. Okay, so the name variable holds the value input by the user, but remember that it's gonna be string always. Raw input is going to return us string. When you try to print welcome name, we get welcome Chuck. Chuck is the value which user had in input. All right. Converting user input. Let's say what happens since we discussed that raw input always returns us a string. What if you don't want a string? What if user wants to input some number over here? Let's see how to do that. Converting user input. All right. So if you want to read a number from the user, we must convert it, all right, from a string to a number. So what we are trying to do here is we are trying to get the floor number. As you can see, the diagram here tells us clearly that we're trying to we see a lift over here which has numbers, and we're trying to get the floor number we want to go to, say Europe floor, right? Give me the Europe floor, tell me where the Europe floor is, and we put this string, and remember this string is going to be a kind of help string, right? So user gets this, and it waits for the user. All right, what happens is this help string is displayed on the console. All right, and then it waits for the user to input something using the keyboard or something, right? And user inputs 0. And remember, we saw that raw input is going to return us a string, not a number. So what INP will get is 0 in string form. INP will be this. It is our responsibility, if we want to use this particular string as a number, we need to use appropriate type conversion function. So we tried using integer because we know that the floor number is going to be an integer. We try to convert this particular 0 string into a number 0 and then add 1 to it, store it in USF, and when we try to print USF, we get US floor is 1. So I hope this is clear that how do we take input from the user using the raw input. But the point to note down here is that raw input always returns as string, alright, and it is our responsibility to take care of converting it to the appropriate data type using our type conversion functions like int or float and so on. Alright, let's see another aspect, which is comments in Python. What are comments? Comments are, comments are something which do not get processed again. They are just for readability or describing the context of program. Alright, so let's see. Anything after a hash is ignored by Python. As I said, that it does not get processed. It gets ignored by Python while executing. So anything you see post or following hash is called a comment. This particular hash is used for single line comment, and the double quotes or the string type. So whatever you type in between the quotes is multi-line comments. Alright. So typing in, let's say, our description of the function. We wrote a function and we want to tell that what this function does. So probably if our function is can be described using a single line, we would use single line comment. If it has to be described using multiple lines or a paragraph, we should use the multi-line comments. Okay, so as we said, it is for readability, point 1, describing the context of the program, point 2. So let's see what is this. Describe what is going to happen in a sequence of a code. So describing our code, documenting who wrote the code or other ancillary information. Turn off a line of code. This in fact is a new thing, right? What does this say? Turn off a line of code, perhaps temporarily. So let's say I have a code which says print hello, and I have this in a file, and probably as of now I want to turn off this particular line of code. What I would do is, since this is a one line of code, I don't want Python to execute it. I would just put a hash before this. This turns my code inactive for the time being. If I want to activate it again, I would have to remove this hash. All right. Okay. Now this particular program, which we have been seeing from the session 1, has come again. But let's see what we intend to explain in this particular slide is the yellow part. The yellow part tells that these sentences, these lines are all comments, isn't it? Comments, and hence they do not get executed, they are not processed, but are used for describing the functionality of our code. And what it describes is, as you can read here, get the name of the file and open it. So it tells that the following piece of code does this. What it does? It gets the name of the file. So raw input is getting the name of the file and open it. We're trying to open the file, right? So just a little description of what we intend to do in our code. This is when the comments are used, and they are very much useful if you want to ship your code to someone, and if there are no comments, what is going to happen is probably they won't understand your code, and maybe they would have to get you on board to explain your code again. All right, now let's see some more operations. We just saw that plus implies concatenation. When it implies concatenation, when we are dealing with strings. All right, there is another type of concatenation, which is multiplication. This asterisk implies multiple concatenation. Let's see an example over here. So ABC plus 1 to 3 is normal concatenation of two strings, which gives us the concatenated or the added string as ABC 1 2 3. Let's see how multiple concatenation is done. We have a string hi and we multiplied, that is asterisk of 5. So hi is repeated 5 times and we get the output as one long string, which is basically one string multiplied by 5 times, concatenated 5 times basically. Alright, so we also have seen this, that Python knows when it is dealing with a string or a number and it behaves appropriately. We don't have to worry about it, and that is the beauty of Python. Alright, now one more thing to remember here is regarding variables. We saw some rules which gave us an idea about the proper or the correct defining the variable names, giving the variables an appropriate name. All right, now as we see, what also we should remember is giving the variable names as per your program function. Say for example, your program is working on doing a square of a number, and if you name your square variable as something as s is equals to x asterisk x, or probably x power of 2, since this is a square, right? So this is probably not a good idea to give your variable a name, though it is valid as per our rules. It is of course valid, but giving this name such as s does not look good and does not give us a clear picture of what this program is gonna do. So probably we would want to do is that give the variable a name which is memory aided, like people can remember and try to understand better what the variable is intending to do. So we can probably give this a name as square, and remember square is not a reserved keyword or reserved word, so we can go ahead and use this as a variable name, and we can say square is equals to x into x. Alright, so this also we should keep in mind. And again, like x also isn't, this is just an example. We were trying to correct s here. We should also correct x over here. Right. Or we can say square is equals to number into number. Alright, this is a good way to do the programming. Alright, let's proceed further and let's see what we were talking about. Right, now just see, have a look at this. This is our variable name, and who in this world could understand probably what this variable does? Alright, so this is not a good idea. Good idea? No, a big no. It is not a good idea. Alright, and the same program is written with a good variable names here. So we're trying to compute the pay and these variable names does not look good relative to our computation program. It does not clearly tell what exactly we are trying to do. All right. Now we have an exercise to do at this point of time. So probably you can try writing a program, Python program to do this. What you need to do is write a program to prompt the user for hours and rate per hour to compute the gross pay. So when we say prompt the user, this is taking user input, taking the input from user. All right. So let me just um, unmute you. Do you have a question over here relating to this program, Yan Wang?
No?
Do you have a question? Do you understand this question?
Yes, yes, I understand.
Okay. And I would like you to solve this problem and submit to us.
Mm-hmm. On the problem comments. Okay.
Yeah. So what I would do is I would be sharing this slide with you. All right. So you don't need to write down the problem. If you write down, not a problem, but I would share the slide so that you can refer it later and write a program and send it back to us.
Okay.
Sounds good?
Sounds good.
Okay. So let's see what we discussed as a summary for this slide. We discussed about type of the data. We discussed about the reserved words, variables, and how do we define them, the rules to define a variable, and also we should take care of the mnemonic, that is the memory aided naming conventions to be followed for variable definition. All right, we saw a few operators which were mathematical, in fact, in this particular case, and then we also saw that during the evaluation of the operators or the expression, which will be given the precedence. All right, we also saw integer division and division of mixed types, that is integer and float. All right, and we also saw conversion, that is the type conversion functions, which were int, a float, and str. All right, and we also saw how to take input from user is using raw underscore input function, and at the end we saw how do we write comments. All right, so any questions so far? Were you able to get this?
Yes,
Okay, sounds good. So shall we proceed further with the next slide?
I think so.
Pardon?
I think so. We should
Yes.
proceed to next.
Yes. So I'll just present over the next slide in a while. Yep.
Mm.
Okay. Okay. So let's begin with our next topic of discussion today, which is conditional execution. All right. Now we saw here till this point we have been discussing about statements, which were probably sequential. In the first session, we discussed about three aspects of a program. We discussed about sequential execution. We also discussed about repetitive steps. Okay. We also saw about the reusable, which were functions. All right. Now we're going to discuss about conditional execution. And yes, I did not note down there was conditional also a part of session 1, conditional execution, which was just a brief overview. We're going to discuss the conditional execution in detail in this slide. All right, now let's proceed and discuss in detail about conditional execution. So what is conditional execution? As we discussed in our previous slide that some steps are not mandatory and can be skipped. All right, so some steps are optional. All right, so this is the same, in fact, the program we saw. X is 5 and based on a condition, and we also discussed in the session 1 that the condition evaluates to true or false. What are true or false? These are two Boolean values. All right, now in this particular case, x is less than 10 is the condition, and what is the value of x is 5. Is 5, we need to ask ourselves when we're writing code, is x is less than 10, which is 5 is less than 10, true? It evaluates to true, and the following statement of the conditional block gets executed. Now to be noted here is indentation. We also discussed about indentation on our first slide. If not, we are going to discuss this further in the following slides. All right. So what happens is we are focusing on the condition execution part, and we'll see the syntax part later. Now, since this condition evaluates to true, we get this piece of code executed, which gives us the output smaller. And we have a following condition, which is x is greater than 20. Now x is 5 is greater than 20. This evaluates to false. And this isn't printed. And at the end, this has no condition associated with it. We don't see an if or any conditional keyword. If, in fact, is a keyword which is used for writing conditions. All right, we don't have a conditional keyword over here, so this is executed unconditionally. All right, now let's see. In the last session, not in the last session, in fact in this session, in the previous slides, we saw mathematical operators. Here we have comparison operators. Mathematical operators were used to perform numerical calculation. Comparison operators are used to do the comparison. So let's see what are the comparison operators available to us. Okay, the comparison operators are listed over here, which is less than, equal to, equals to, greater than or equal, greater than, and this is not equal. We will see an example which will make us understand these comparison operators better. We should treat this as Boolean expressions, asking us a question and produce a yes or no. We just saw in the previous slide that any condition evaluates to either yes or no, which will be used for controlling your program flow. And that is how your steps are either executed or not. Alright. Also to remember here is comparison operators do not change the variables. They do not alter our variables, rather they just compare and they give us a result which evaluates to true or false. Let's see an example. We assign the variable x a value 5. Alright, now we're trying to compare the equality. If this is equals to operator, equals to comparison operators, as we discussed in our last slide, right? This is the equality. It checks for equality, whether the variable is equals to a value, or also we can have, in this place of value, we can also have another variable, right? Okay, so this in fact is equals to 5. X is holding a value 5, which is in fact equals to the numerical value 5, and hence the following block of this condition executes and we get the value equals to 5. X is greater than 4 is our next condition. Yes, it is greater than 4. This evaluates to true, and the following block, which is this line, gets executed. We get this output, and so on. All right. So this also produces less than 6. This is less than equals to 5. Now less than equals to 5 is something like it is either less than or equals to 5. In our case, it is not less than, but since it is a combination of basically two separate entities, like if either one of them is satisfying, our condition evaluates to true. In this case, x is 5, so the later part, which is equals to 5, satisfies, and hence we get this output. X is not equals to 6. Yes, x is what? X is 5. 5 in fact is not equals to 6, and hence the following block executes. Alright. Okay, now let's see different sorts of decision making. Now we saw that we can make decisions, or we can control the flow of execution based on conditions. Let's see the different ways we can try to do this. So we have x is equals to 5 again. We try to print this. Since it is a sequential step without condition, it prints before 5, isn't it? Alright, now we have a conditional statement here. X is 5. Yes, in fact it is equals to 5. The following block of code, this particular 3 lines of code, creates a block of code under this condition, and hence it is indented, executes, and we get all these 3 lines as the output. Let's move further to this program and print afterwards 5. This unconditional step executes. Again, this one also executes. There is no condition to it. It satisfies, it executes. Alright, let's see this now. This particular thing has a twist. Now x is equals to 6. Is x equals to 6? We need to ask ourselves the question. Is x equals to 6? No. X is 5 and 5 is not equals to 6. This evaluates to false. The following block, which is again these 3 lines, does not get printed. And what gets printed is the last one, the last print. which is unconditional, gets printed. So you see what we are discussing here is one-way decision. So we have got only a single way to move, either this one, the conditional way is one. So it again comes back to the main execution. This is our main execution. The condition, if it becomes yes, gets its way, comes back to the main way. Okay, so I can see a question from you. I'll just unmute you. So let me just, so your question is, does the computer judge whether a line is under an if condition or no just by the indent? Oh yes. So your question is uh, valid, completely valid, and the answer is that yes, Python judges the set of statements under an if using only indentation, and we will see further that how exactly indentation works in the following slides. Does that clarify? Okay, cool, fine. We'll see further, and at the end we will answer the overall questions. All right. Okay, here is the answer, in fact. Okay, so indentation is a very important aspect in Python. If you don't indent your code properly, you're going to get a lot of errors in your program. Let's see how does it work. Increase indent. So hope you understand by indent. Indent is nothing but your alignment of your code or your statement. That is the spacing out or spacing in is basically called the indentation. All right, we're going to see how exactly it works. Right, so increase indent. So you need to indent, increase the indent after an if statement or for statement. So what is the syntax of writing an if statement? If statement is nothing but writing your condition statement. So you write if and you put your condition over here. All right, and then you put a colon. You see this colon marks the end of condition. End of condition. All right. Okay. Now, what happens is at the end of every if or for, we need to give increased indent. That means increased spacing. All right. Maintain indent to indicate the scope of the block, which lines are affected by the if or for. We saw right over here. So here is the if block. Here is the if condition you wrote, and colon marks the end of the condition statement. But the block which will be written, the statements which will be executed based on this condition have to maintain an indent. You see, all the indentation over here is maintained. They are at the equal spacing from if. If let's say if is at 0 indent, the following statements which we want to execute under this condition are going to get some spacing. This is the spacing I'm talking about. This spacing is indenting, giving a space right? This is called indentation. So we are trying to increase the indent after every if of our statement. See, we increased, the indentation was 0. After the if condition, it became 4, probably, because the standard indentation is 4 spaces. So the ideal indentation is 1 indent is 4 spaces. This is what the Python standard says. You need to give 4 spaces for indenting your code. Alright, now the next step, first step we saw is increasing the indent. Another we saw that maintaining the indent. What is maintaining the indent? We maintain the indent for the following statement to the if or for to say that all these three or all the following statements are under this condition and will be executed under this condition. All right. Now reduce indent. Let's see the third one. Where do we need to reduce the indent? As we talked that it is all about indenting the code out or indenting back in, right? So when do we reduce the indent? When we want to go back to the level of the parent statement, that is if statement or for statement. Now, important thing to note here is to indicate the end of the block. When we want to end, when we want to tell that, hey, my block of this conditional statement is done. I'm done with the if condition. I want to indent out. Let me rub this. Probably this has become very untidy. All right. What I mean to say is when we wanted to block a code, that we wanted to say that these 3 lines of code is under if, we indented 4 spaces in, out, in fact, right? And when we say that I'm done with these statements, I need to move out, I indent it back. I give 4 spaces, I remove 4 spaces. This tells Python that my block of this conditional execution is done. I'm done with this if, and the following statements are not going to be part of this if. Whatever is following is not going to be part of the above if condition. All right. See an importance of indentation in creating block of code. Right. Blank lines does not actually matter. Blank lines are ignored, so they do not affect indentation. All right. What does this mean is if you write a line, say if condition, and we give a blank line over here, and then we say print, this line is really not going to affect our block of statements. Okay. Even the comments on a line are ignored with regard to indentation. Okay, this will become more clearer when you write some code, some piece of code which requires indentation. That will give you a clearer picture. All right. Okay. What we need to take away from this slide is when do we need to increase indent, when do we need to maintain the indent, and when do we need to reduce the indent. This all is done to block the code. Okay, here's a warning for us. What is the warning? Is turn off tabs. We should not use tabs to indent our code because tab is programmable. You can change the tabs, right? So most text editors can turn tabs into spaces. All right. This is in fact a feature, but the warning for us is that you might get errors if you mix tabs and spaces. you may get indentation errors while executing the Python code. Alright, so we should not mix up tabs and spaces. Also, we should avoid using tabs. Instead, we should use spaces. This is the way to do. Okay? And in fact, if you use any IDE, like we discussed in the session 1, if you're using, say, Eclipse or PyCharm or any other IDE which really supports Python well, will indent your code automatically. Alright, now let me just try to see if I can demonstrate this. I will just pull out idle for now, and let me just show you if how does IDE indent your code. All right, this is my IDE window, and I'm trying to write an if block. So I write if, or let me declare a variable like we did before. X is, let me just increase the size if I can. Zoom height, no, zoom height doesn't work. Okay. Okay. As you can see over here, this again tells one more thing, that how can you change your the value of spaces. So as you can see over here, this particular thing setting says that you want to indent with how many spaces, and here you tell that, hey, I want to indent with 4 spaces. All right, the setting is now done to 4 spaces, which is the standard one. All right, what I'm going to do is I just want to try increasing the font, and let's see, apply. Okay, I hope this is visible now. Okay, so what I'm trying to do now, if x is equals to 5, I put a colon here. All right, I try to hit enter. You see, I automatically get an indentation, which is equals to 4 spaces if you count 1, 2, 3, and 4. All right, so let's go to the end and try to hit enter again, and we reach an indentation because it's an intelligent IDE, and that is why I suggest people to use IDE to write Python code, because you don't have to worry about indenting your code. And it actually color codes your keywords also. If you see the if here is color coded, it's in orange color, it tells the keyword. All right, so I hope this explains. Now if I try to write a code here, and see again, now I am again indented to the same block, because Python expects the programmer to tell whether your block has ended or not. All right, now if I want to end this block of code, I'll just put a backspace and go back to the main stream. That is, I have moved back 4 spaces, and I can write an independent statement. Let's say finish. All right, now this is what the importance of indentation is, to block the piece of code under a condition or a for loop. All right, I hope this explains. Let's proceed further. All right, let's proceed further with this. Okay, this is what I was talking about, and we just saw this particular setting, the setting of indentation, or in fact here we are talking about tab size. So the tabs, why we discourage using tabs is the tab size can be modified, and if say some editor has a tab size of 5, I have written my program using the tab size of 4, it actually creates the conflict, and there happens the problem. Okay. All right, this is a very well showcased color coding of how you write or maintain the indent. You see, when we are trying to write this, the parent block of code, yellow coding. Yellow coding says maintain. So I'm maintaining. Right now there is no blocking of code. I'm not blocking any code inside any conditional block or a looped or a repetitive block of code. All right. Now here I am saying that I want to execute some statements based on this condition. I want to increase the indent, isn't it? This is what we discussed. When do we want to increase the indent? When we want to put a block of statements under any condition or repetitive steps, isn't it? Okay. Now, since when we are done with the execution of this these steps, we say I want to decrease the indent. I'm done with writing the if condition and the following statements. I decrease the indent. This is what it says, and I move back 4 spaces and write to the main execution line. All right, and so on. If you write the same for loop, the similar happens. All right, now here also we see that it is nested. This is important note that now I say that print I is under for, even the if I is under for. Okay, but now since this is another if inside for, and this if again in turn will have its own block, so I increase the indent further. Now you see this is nested indenting. I indent one block to mark that these statements are under for. I indent furthermore to mark that this statement is under if, which in turn is under for. Alright, this is very important to note, and in fact this will be clear when you write lots of code. You will understand this much better. Alright, okay. Think about begin and end blocks. This is what we're talking about. We said that this green mark, green block, this complete block is under for, and the piece of code, which is the piece of line, this piece of line, a single line, is in fact under this if itself. So this has 4 spaces indentation. Again, this has 4 spaces indentation. And when we want to end this green block, we have to move. Let me clear this. So we want to move 4 spaces out. And again, when we want to end the for block, we want to move furthermore 4 spaces. Sounds clear? All right. Now let's see. We just saw one-way decisions. Okay, that is, let me just go back. Yeah, we just saw one-way decisions. That is, if we have one way, that means we do not have an alternate way to go if the condition dissatisfies. That means it comes here, executes, it also comes here, executes, and does no other way. I mean, that does not have an alternate way to go if this does not satisfy. It does not have an alternate execution, in fact. All right, we'll see how two-way decisions or nested decisions work. All right. Now let's see the nested decisions. How nested decisions work. All right. Nested decisions are decisions inside decisions. So we have this first decision, x is equals to 1. We try to compare the value of x if it is greater than 1. If yes, it goes this way. Alright, it follows this way. And we try to print something if this is satisfying. That is, if x is greater than 1, we're trying to print this. But we have another condition on this way. That means we are already under one condition. We're trying to put another condition. Right? So this condition comes under this condition. And that is when we call it as nested condition. Alright, now what happens is if this condition satisfies, we go this way, execute this statement, and we try to compare another condition. So if x is less than 100, we do this, or else we go back to the main string. Right? So we have what we should take away from this slide is we can have one condition, another condition, under a condition. We can have one condition under another condition. We just need to take care of the indentation part. The syntax of the condition remains same. Alright. Now let's see, we just discussed about one-way conditions, which was just following the format of one way, that is, if this, yes, true, what to do, if this, what to do, right? It is following a single way, right? And we also saw how a condition is defined under a condition. All right, let's see how a two-way decision is made. What if we want to compare a condition and we want to execute two conditions relating to this? Let's see what it says. Sometimes we want to do one thing if a logical expression is true and something else. This is to be noted, right? Sometimes we want to do one thing if a logical expression is true. Otherwise, we want to do something else if the expression is false. Let's see what we mean to say by this. We mean to say x is 4. If x is greater than 2, we say it is a bigger number. All right. Otherwise, what to do? It is not bigger. Now we are performing two operations based on two ways. So both the ways has its operations. Okay. So you can consider this as a real life scenario, that it is like a fork in the road. Right? You reach a fork in the road and you have two ways to go. Right? Now at this point of time, okay, you're moving this way, your car is here, all right, you're moving this way, you have a fork here. Now you have either way 1 or you have way 2. All right, now you must choose at this point of time which way do you want to go. You want to go the way number 1 or way number 2. All right, this is called two-way decisions. Either you would go follow the way of yes or the way of no. All right, and both will lead to your some destination. All right, now let's see the exact code of it. So this is how you write two-way conditions. Now we have another keyword. In a single way, one-way decision, we just have had if keyword. If we want to make two-way decision, the two-way decision will follow this syntax. That is, it will follow if or else. It's like we asking ourselves, if this happens, I want to do this. Otherwise, I want to do this. You get this? Now, else part, else keyword does not have a condition. This is to be noted. Why it does not have a condition? Because else always follows an if. Else cannot come standalone. Alright, so else will be followed by an if to complete a two-way decisional statement. Alright, so we will say if x is greater than 2, we print that it is a bigger number. Otherwise, else. Remember again that else is a keyword, is another condition, is the second way to this conditional block. It is the second way to the conditional block, which will have to come along with an if. It will follow an if always if it is a two-way decision. We will also focus in our further slides about multi-way decisions. Alright, I hope this two-way decision is clear. Alright, and we will take the questions at the end probably. Alright, let's proceed further with, okay, this is a pictorial representation of the how you relate diagrammatically to this code. Alright, so let's discuss about another one, which is multi-way decision making. So far we have discussed about one-way decision making, nested decision making, two-way decision making. But what if we have multiple ways to choose? Alright, like say we have the condition of either number can be small, it can be medium also. Till now we were dealing with either a small number or a big number. Now we have to categorize a number as either a small number or a medium number or a large number. This is the place where you should decide to use multi-way decisions. Alright, so how we say, if x is less than 2, I will print that number as a small number. Elif. Now remember here, we have another third keyword, which is short form for else if. You might have used probably in other languages else if. Here in Python we use this short form to represent else if, which is elif. Alright, so what we are saying that to make multi-way decisions, elif is very important. Also to note down here is, in a multi-way decision, else will always be at the end. Else will be the end marking of this complete block. It will always mark the end of the block. That is, it might be treated as the last condition. If none of these satisfy, so how does it work? Let's see. So if x is less than 2, we would say yes, it is small. Now remember, either one of these will be executed at one time. Either one of these three conditional blocks will be executed at a time. Alright, so if x is less than 2, this will be executed and no more execution will happen under these two. And it will come directly out here and it will print all done. If this does not satisfy, it goes to, if the first condition does not satisfy, it goes to the elif part. And if this satisfies, it prints medium and it does not execute else part. It goes out and prints the all done. What if, let me rub this. So what if Even this does not satisfy, and this does not satisfy. The last resort, as I discussed, will be executed in that case. That means if both of these does not satisfy, this is the execution which is going to happen. All right. And this is the pictorial representation of it. See, orange color changes. So if we take an example of 0, if x is 0, 0 is less than 2, print small, and you can see the orange line going directly out of this conditional looping, not looping, and conditional execution, and it directly goes to all done. All right. Now, if we take an example of x is 5, now 5 is not less than 2, is it? Not, right? So it does not go here. It goes to the next check, which is under elif. Yes, it prints medium, and see, it directly again goes out of this conditional execution and prints all done. Last type of thing, if x is 20, so it neither executes this nor executes this. It goes to the else as the last resort, executes this, and goes to this particular unconditional execution. All right, I hope this is clear. This is the same as that, but now the point to be noted here is instead of three, now we have many actually multi-way decisions. So if we are considering now small, medium, big, large, huge, enormous, right? We have categorized our number as many. So remember the execution flow. It will happen this first. If this satisfies, it goes directly out of it. If this does not, goes here. If this satisfies, it executes this, goes out. And if none of these execute till elif, last elif, so the middle one, you have to remember that first keyword to be used in a multi-way decision is if. The following, but not the last one, will all be elif, and the last one would be else. All right. Okay. Now here I have a puzzle for which I will just unmute you and let me just unmute you and you can try answering this question. Can you hear me?
Yes.
Yes. So can you read out the code over here?
Yes.
Okay. So what I want you to try out and giving an answer. So I have two block of code. So this becomes question number 1. Okay. This piece of code becomes question number 2. So I want you to try this, that which of these conditional execution will never happen.
Mm. Something else.
And why do you think so?
Because if you input a number is either less than 2 or larger or equal to 2.
Exactly, you're right. Thank you. So either a number could be less than 2 or it can be greater than or equal to 2. There is no other way to go. All right. So that's fine. That's the correct answer, in fact. All right. So also, can you try on the code number 2?
Mm. Print below 10.
Below 10. All right. And why do you think so?
because below 10 is in the range of below 20 and is after below 20. So if a number is actually less than 20 and larger or equal to 2, it will the second line will execute it, which is below 20. And
All
below
right.
10 will never be executed.
Right, right. Absolutely correct. I appreciate your answer. Thank you very much.
Thank you.
So this makes sense, and I think you understand it better now, right? Uh,
Mm,
all right. So let's proceed further. Yeah. Thank you very much.
thank you.
Okay. All right. So here was the puzzle. Okay. Let's see the try and accept structures. Okay. So what if your code is going to give some errors? Okay, what happens if you have some error during the execution of the code and your program terminates immediately following the error, but you don't want your program to terminate um, abruptly, and rather you want to handle the error which has occurred. So these are the statements, these are the keywords which will be used to rescue at this case. All right, and let's see how to use them to catch your errors and handle them. So try and the accept structure, right? So what you basically try to do is that you actually try out your code, the code which is dangerous, the code which you feel that might cause some problem during the execution. You put it under a try block, and you keep an except block following the try block, which will catch the error which has occurred in the try block. So if the code in the try fails, if the dangerous section of code which is kept under try, if it fails, it jumps to the except section to handle the error or the exception which has happened. So exception is nothing but an error event. All right, is called an exception, which happens, an error which happens at the runtime. All right, which we will be trying to handle using the try and accept. All right, let's see. Let's see a type of error. So we try to run a file which is notry.py is the file name. And what does this file do is see. We have a string hello Bob and try to convert this string to an integer. But will it convert this to an integer? No, it will not be able to, because this string has got no numbers in it, and hence it gives an error. What is the error? Look at the error which has been thrown by Python is value error, invalid literal for integer with base 10. So it really does not was able to perform the conversion, right? So we will try to, so now in this case the program has terminated throwing this error. Rather we would try to handle this using the except block. Okay, now see what is the red thing. We have furthermore statements to follow, but since the error has occurred at this point of time, at this statement, the further execution does not happen and the program terminates. But this is bad. We would not want our program to terminate this badly, right? So our program has terminated at this point, which we really don't want. All right. So this is a very high level picture of um, where does your processing happen, and you have main memory and CPU talking, and then you have a secondary memory. Okay, this is just the basics of it. And okay, let's see now, let's jump into how exactly try and except block rescue us from the situation of abrupt execution or termination. All right, so we try to execute this particular file, and what do we have in the file? Let's see that we have a string hello Bob, and we try to put the conversion. Now we know that this is a dangerous code. And why is it a dangerous code? Because the conversion might fail in cases of converting a string to an integer which does not have a number. We just saw an example of it, right? We try to convert a string to an integer which does not contain a number. All right, and boom, this is our dangerous code. So we always try to put our dangerous piece of code inside a try block. We call this as a try block. Okay, and the try block is going to contain the code which is we might feel as a dangerous code or might throw error at runtime. And following the try block, we have the except block. Following the try block, we have the except block, which will catch the error which has occurred in the try block. All right, so whatever error happens over here, we're trying to catch that error and handle it rather than terminating the program, right? And what do we say is, if the error happens, we're trying to reassign this istr to -1 and proceed further. So now you see the program is not going to terminate abruptly, rather it is going to give some sort of output, right? And what you see, the output is here. All right, so now in our case, what is going to happen is hello Bob is assigned to ASTR, and the try block executes, which again tries to convert this hello Bob to integer. But since it fails to convert ISTR, this directly jumps over to the except block with an error. Except tries to catch that error and reassigns ISTR to -1, and at the end we get the output as first and -1. All right, now we have reassigned ASTR. This is another example in the same program. Okay, now we have ASTR as this string which is 1 to 3. All right, now 1 to 3 has this string has numbers in it. All right, now this will succeed, and that is why it has marked as green. So in this case, in this input, this particular conversion is passed, and hence it does not go to the except block. Remember, the try block is executed, and if there is no error, the except block does not execute. Okay, all right, so that means ISTR is not reassigned, and then we get output as second and the exact converted number. Isn't it good? See how efficiently we are able to handle the problem of errors in this case. All right, and this is what we saw is the pictorial depiction of how it executed. Okay, this is one more example. We tried to take input from the user as a raw string. User gives some string. We try to convert it. So instead of doing that, like manually assigning it, we have got it using raw input from the user. All right, but the try and accept remains same. All right. Okay, now I have another question for you here. Another question is that the previous question we had, we're going to do the same question using the try and accept. Okay, so this was the previous one, and we now we want to rewrite this using try and accept, and we want to handle the possible errors. All right. Okay, let's look at the summary. Uh, the summary is we discussed about comparison operators, equals to, less than, equals to, and we need to remember they evaluate to true or false, all right, and they do not change the variable value. Okay, we discussed about and or not. And or not is nothing but, you know, the expanded version of this uh, is greater than or equal to. So we saw that if you want to compare x greater than equals to 5, it actually means x equals to 5 or x is greater than 5. All right, so these are the or and or not operators. So since we did not go inside of it in depth about it, but we overall discussed about the expansion. So if in the further slides we would discuss it more in depth, with more programs. Okay, we discussed about indentation. When do we use indentation for blocking our code in if, in for, and we also did that in fact in try and accept, right? We also discussed about one-way decisions, two-way decisions. Two-way decisions are done using if and else. We discussed about nested decisions, multi-way decisions using elif. We explored a new keyword, elif. So basically we talked about three keywords, if, else, and elif, to create different sorts of conditional executions. We talked about try and accept to compensate for errors, to catch our errors, and we learned that we should always keep our dangerous code inside a try block, and we should try to catch the possible errors in the accept block, and hence we should stop our program normally rather than abruptly. All right. Uh, Yeah, so we come to the end of today's session, and I would quickly ask if you got a question out of this. Yep, so we can discuss quickly about your questions. I have turned your audio on. You can speak up if you have any questions. Yep. Do you have any questions, Yanwang?
No,
No,
not yet.
nothing yet. Was everything clear today?
Yes,
Okay, sounds good. Thank you very much for attending this session.
thank you.
And we will meet for the next session on 27th, that is day after tomorrow, Indian time, 8 p.m. to 10 p.m.
Okay,
Okay, thank you once again, and have a nice
thank
day.
you. You too, thank you.
Yep.